Hello all, welcome to another video of mine from Introduction to Embedded System Design. So here we have the block diagram general purpose processor. So here there are some components like sequencer, data path. The sequencer has a small components in it called the control logic, instruction decoder, program counter. So the program memory has the address bus and the control bus. So address bus is to transfer the address data, address related informations. Control bus is used to transfer the control signals. Data bus is used to transfer the data signals. Data memory is used to store the data related informations or the raw information. So address bus and control bus would be present both in the program memory and also in the data memory. So the data path is the block diagram, which involves subcomponents like resistors, general purpose arithmetic logic unit. Arithmetic logic unit will be used to perform the arithmetic operations like addition, subtraction, multiplication, and division. And logic unit is used to perform the logical operations like AND operations, OR operations, NOR operations, and NAND operations. So the next one is single purpose processor. Single purpose processor is also an embedded system block diagram. This involves the main block called sequencer, which communicates with the data processing elements. The data processing elements can be a decoder, which decodes the information after receiving the information, adder, and encoder. Encoder is for encoding the signal, converting the signal from one form to another form while transmitting. Multiplexer will combine the signal into one. Demultiplexer will demultiplex and divide one signal into several signals. So that is the main purpose of multiplexer and demultiplexer. So these data processing elements like decoder, adder, encoder, multiplexer, and demultiplexer will be considered as the data path. So this data processing element will send the data through the data bus to the memory. So inside the memory, we will be having the address bus and the control bus. So this is a main block diagram of single purpose processor. So next one is a general purpose processor based embedded computer. So this is nothing but the block diagram of 8085 microprocessor based roulette. So this microprocessor will be having the clock signal, write signal. When WR bar is 0, then write operation happens. When it is 1, then write operation will not happen. IO/M bar is used for input-output operations and also for memory operations. RAM is used for random access memory, decoding the circuit. Uh, we decode the circuit, we decode the informations, and then it will be converted, it will be given to the random access memory. Decoding circuits are three in number. Two are sub-decoding circuits, and one is a main decoding circuit. Demultiplexer we have, which converts all the signals into one signal. So the bits are there. Address/able is there. Address and data bits are there. Electrically erasable programmable read-only memory we have, and latch we have. Latch is nothing but the buffer which is used for temporary storage of data. So the latch will be connected with the LEDs, and it will be also connected to the output device called LCD display. So this is the main diagram of general purpose processor based embedded computer. So we have power supply, we have reset. So this is nothing but the individual block diagram of the components which was discussed in the previous slide. So this is the reset operation, power supply operation. Inside the power supply, we will be having the rectifier, electrically erasable programmable read-only memory we have with pins, random access memory capacity is 8 kb. Decoding circuit is considered as a memory. Demultiplexer is used. The IC chip of demultiplexer is given here. The square wave generator is used here. The decoding circuit, we have three decoding circuits in the previous diagram, right? So the decoding circuit general diagram is given here. Pin diagram is given here. Likewise, the 8085 microprocessor IC diagram is also given in this picture. So this is the photograph of 8085 based roulette wheel game. So here we have all the setup, and the output will be displayed in the LCD. So here we have 8085 microprocessor, the decoding circuit, multiplexer, the reset operation, the latches, and the wires, connecting wires are given to the output. And LCDs are there for indicating the levels, wheel levels. So application specific processor based embedded computer. So this is the block diagram of Arduino based roulette. The microcontroller is there. So this is a simple diagram where where we connect the microcontroller with the latch and with the output device or the 7-segment display, which is then connected with the LEDs. So LED is also an output device. 7-segment display is also an output device. So this both is to view the output. So power supply diagram, clock source, microcontroller diagrams are given here. So this is a block diagram of a CPLD based roulette. So where we have the decoder for decoding the received data from one form to another form readable by the microcontroller. We have the reset, clock generators we have power supply, finite state elements are there, and the LEDs are there. So this is the next diagram for CPLD based roulette. This is the implementation of roulette. So this is the programming which we will be using. I hope you would have found the video to be useful. See you in the next video. Until then, it's bye from Radhika.